Hi guys, today let's talk about what is a Docker and how to set up the Docker in the Mac. I will also give the instructions to set up the Docker in the Linux and Windows as well, and how we can deploy the Spring Boot application with the Docker. Basically, how we can Dockerize the Spring Boot application. Let's talk about that. So basically, the Docker, we say it's a containerization. So what is a containerization? So when you see the logo for the Docker, it has a basically ship where it is carrying the containers. So most of these symbols has a meaningful definition for it. So when we talk about the Docker containerization, so basically nowadays, every application, not nowadays, even in the previously. So we deploy our applications into the servers. Basically, those are on-prem or the cloud servers. Earlier, we depend on the DevOps team in order to run the application into the servers. As a developer, we just create, build our application. Build is nothing but, once the application development is completed, we push our application into the repositories. That's a version control systems. It could be Git or Bitbucket or any other version control system. And then the build is going to trigger from the either Jenkins or any other the build system. And it's going to create an artifact. And the DevOps team is going to have some script which takes the artifact and run it to the different servers. That is the process that we follow. In order to run the application, assume that I want to run a Java application. In order to run a Java application, we need to have a JDK installed in the server. Assume that JDK 21 we have to install. So the DevOps team has to copy the JDK 21 into the server and run that. Assume that JDK has a multiple versions. Maybe the DevOps team has installed JDK, some of the version into one server. Maybe the same application has to run into the multiple servers. Maybe they're going to install the different JDK subversion into the different server. So maybe, both the JDK 21, it has a subversions, could be some fixes. So maybe our application is failing in one of these node. So when you deploy our application and the QA team is started testing, so they identified some issue. As a developer says that my code is working fine in my local, and when the application is running in the server, it is failing. It is not my issue. So definitely there are some conflicts between the developer and the QA. Since it's not working, so the QA is absolutely correct because their point of view, the application should work as expected, but it is not. So that is the one of the reason we have the containerization. That's one of the primary reason. We do have other reasons. We will talk about it. So now, after we have the Docker containerization, as a developer, we know what is required to run our application. Since it's a Java application, we need to have a JRE, Java Runtime Environment. We don't need to worry what is there in the server, right? So now, every server need to have the Docker installed or Docker supported servers, right? So now, as a developer, you're just going to create an application and we are going to create something called a Docker file. The Docker file is nothing but a set of instructions to run our application in the container. So now I'm saying it's a container. Basically, the container is nothing but our application, what is required to run our application. Anything else is needed to run our application. It could be maybe some agents Maybe we need to have some monitoring agents, or we need to have any other work directory that we need to create. Could be a set of instructions, a part of the Docker file. So that is the Docker file. Now there are two things generally people talks about. One is the Docker image and a Docker container. What is the difference between an image and a container? So as a developer, we are going to create a Docker file. So once we create a Docker file, so during the CI/CD process, or even in our local, we create something called an image. The image is not runnable. It is not a runnable. It has just the build version of our application, which contains our jar file, nothing but artifact, and the JDK, and any agents to run our application. That is nothing but an image. Whereas the container is the runnable instance. Runnable in the sense, so as part of our Docker file, we are going to write the last step called Java and then jar and then the jar file name, which is going to run our application as an executable jar, right? So now when the application runs, nothing but when we try to run the Docker run, so our application is going to run inside a container. So even though we are going to run our application in the server, it doesn't directly run our application in the server. It is going to run inside the Docker container. So now in the same server, you can run a multiple applications on the same port, but within the container. When you expose your applications, we can have a different port because the server cannot have the same port running. For example, 8080. Maybe I have a, let's say, registration application, and we do have some product application. There could be other applications. We cannot run all applications on the same port. So the port which is running inside a container can be the same, but the port that we expose outside the container, that is a different. So we will talk about all those steps. Now, let's see how to install the Docker. So go to the official, the Docker hub.com site. Let me open that. So Docker download. So when you see Docker download, so it will navigate to the docker.com where we have an option to download. By default, depends on your operating system. It will recognize what to download. Since I'm going to use the Mac version, it will suggest what to download. So this is what I downloaded already and installed. In case of Windows, you just need to download this. In case of Linux, we have to download this. Linux, even without downloading the package also, you can install, depends on your Linux version. For example, if it is a Ubuntu, sudo apt get install docker.io. In case of the Windows, you need to download this package. After that, so if it is not working, so you have to install something called I think a VM. So when you go to this particular download for Windows, it give all the instructions how to set up for the Windows. Once you are done, in case of Windows and Mac, we have something called a Docker running in the top. So let me open that Docker. So you can see this is what you will see the container logo. So since I have other monitor, it is showing up over there. So now we can see this kind of the logo which is running, and you can see here Docker desktop is running, and also it has something called Kubernetes, which comes by default, but I enabled if you want to test anything for the Kubernetes. So now our Docker setup is ready. Once our Docker setup is ready, so just go to the terminal, just search for type Docker images, which is going to list all the Docker images in our system. So every system, if you install a Docker, by default, we have something called Docker registry. That is where all our images will be stored. So our local has a Docker registry where we have all the images. It's nothing but kind of a Git repository. So where we have all the images stored. We cannot store these images into the Git repository. So we have a separate container registries. We do every cloud has a container registry. For example, at AWS has ECR, Elastic Container Registry. Google has, I think, Google Container Registry, Azure Container Registry. Every cloud has a container registries. We do have the JFrog. JFrog has the container registry. There are a lot of container registries where we can store all our images. Right, we'll talk about it. So in the next video, how to push our images into the container registry. In this video, let's just talk about how to create an image for our application and how to run it. I have a Spring Boot application ready. So now what I will do is I want to make this application as a Dockerized. To make this application as a Dockerized, we need to create a Docker file. Let's create a Docker file in the project root. You can create anywhere. Recommended to create it in the project root. We'll talk about the reason. Docker file, the name of the file is a Docker file. So the Docker file, we need to write the set of instructions. So the instructions is going to be what is the base, the JDK image, and what is the argument. I mean, nothing but how to copy your artifact into the container and how to run it. So all those things we are going to write as part of the, as part of the Docker file. Let's start writing it. So it's easy to write with a basic Docker image. So I mean, basic Docker file. When you have a complicated, complex application, definitely we might have some additional steps. Let's say you want to create your own directory in the Docker container, or you wanted to have the logs which is exposed outside. So we do have some of the steps. So the first step is going to be from, and then here we need to specify the openjdk and then tag version. So I'm just giving the syntax. After that, we'll copy from the official Docker Hub site, the tag version, nothing but what is the version of the JDK. And then we are going to take the, there is something called argument. This is, basically the jar file. So the argument, the jar file. So what is the jar file you wanted to copy? So that argument we have to define it, or even directly we can also write a copy. So we need to copy the jar file from which location? From the target location /star.jar. And then I'm going to rename this jar as app.jar. So you can also keep the same name if you want. Most of the people follow the standards as the app means application jar file, nothing else. And then, so we need to have an entry point to run our application. So this is similar to our Linux command. In case of Linux, when you say cp or env, and then, so you're going to give your application.jar, and then, whatever the name that you're going to give, that's going to be the rename jar. It's a similarly, so the jar is going to copy inside our container. Now we need to have an entry point, and then, so what are the commands to run our application? So everything, so generally, if you want to run as a standalone application, we run as like java space -jar and then app.jar. So the same command we are going to write as part of the entry point, which is going to starting point to run our container. Not a container, to run our application inside a container. Java, and then comma. The next command is going to be jar, -jar, and then what is our jar name? App.jar. So which is located in the current directory. So that's the reason we are just giving the /. All right. So now we have to change the first step. Okay. So now, so we need to have a open JDK. Okay. And we have a different versions, I guess. So that is what you can see here. It is a recommend open JDK, egg drop, open use. There are a lot of adapted open JDK. These are the different the JDK versions, and then colon. So we need to have a tag versions. So let's see, is there anything which is recommended? 21 we need. Let's see. Yeah, I can see something here. Okay. Open JDK 21. Okay. Otherwise, let's go to the hub.docker.com. Okay, so let me drag it here. Yeah, hub.docker.com, open JDK 21. Okay, so if you go to the tags, so this is the the image name. So even the from OpenJDK, that is also one of the base image which is created by the OpenJDK people, and they published into the hub.docker.com, which is the Docker Hub registry. So we are going to pull that from the Docker Hub registry. So we need the 21 JDK. So let's search for the 21. So let's see the 21. Okay, so I see there are a lot of 21 versions. So we can take anything. Let's see, is there any 21? Sorry, this is the, yeah. So we have a 21 slim version, I think, which is published 3 months ago, but the JDK was released in the month of September. So December, November. Okay, I think this one should be fine. So let's see when it was published, exact date, if anything is there. I don't see, it was just saying so. It was published 3 months ago. I think we are good to take this. Let's copy this thing, go to the application, paste it over here, open JDK 21 slim. So we are good with the Docker file. Now we need to create an image. To create an image, similarly, Maven build or Gradle build. So we have something called a Docker build. Let's do the Docker build and see whether we are able to create the image or not. So my application has the build ready. So yeah, I need to build again because I added a couple of changes. Let's do the Maven clean install. Once Maven build is successful, we are going to create the Docker build. So as part of the Docker build, it's going to create the image. The image will be moved to our local Docker registry. So now the build is success. We need to do the Docker build, Docker. So this command you should run wherever you have your Docker file is located. You can see the Docker file is located in the project root, Docker build -t, and then dot. So Docker build -t dot, and then we have to specify before dot, we have to specify what is the name of the image that we need to create. I want to create a KVS assessment evaluation, and then dot means in the current location, which is going to get the Docker file. Let's see whether we are able to create the image or not. So internally what it does is it will pull this particular image first, and then it will copy the artifact as a app.jar, and then it will create a bundle. The bundle will have all the required things to run our application. To run this app.jar, we need to have the JDK 21. So that is what it is going to do. So it's going to copy everything. So I see that it's created everything and writing an image, right? So and I see it is successful. Let's verify the command docker images, then grab KVS, right? So you can see here. So this is the image which is created 37 seconds ago, and the size of the image is 495 MB. Now we need to run this. How to run it? So we have something called docker run -p, which port that you want to expose. There are two things. Put the colon, before colon and after colon. After colon, before colon, it is going to be which port that you wanted to expose. I wanted to expose 8080. What is the port which is running inside a container? So that if you want, you check your application YAML. So it is running on 9004, right? So 9004, right? And then what is the image name or image ID, right? This is what you have to specify in order to run our application. So since it has, the Mongo related connection related issues, I'm getting some issue on the Mongo. That's not an issue because, the container will not be able to access my local Mongo. So that is the reason. So that's not a concern for this to run it. So now we can see the application is started. If at all, if you want to run this application in the background, so docker run -d and then -p. -d in the sense detach mode, -p port, 8080 port that I wanted to expose, 9004, and this is the container, image ID, right? Now, if you want to know whether it is running or not, docker ps. Docker ps will give which containers are running. You can see, since we have given the image ID, so we can see. So this particular, the first one is our application, the port 8080 that we exposed, which is running inside a container, is the 9004, right? You can also specify a container name. So that's not required for now. So now you can see whether you are able to test your endpoint or not. So I have an endpoint, localhost 8080 swagger-ui.html, right? So I'm able to access. I created a simple endpoint which doesn't have any database connectivity. Just click on this admin dashboard, click on try it out, and click on execute. Now you can see the dashboard is coming soon. So this is the message that I printed. So we are able to run our application and see this. How would you know whether your application is really running inside a container, right? So what you can do, there is a command to log in inside the container. I mean, nothing but you can go inside a container. It's nothing but a log into the server, right? So now docker exec execute -it interactive mode, give the container ID, and then /bin/sh. So now I'm inside a container. Whenever you see /hash means we are inside a container. How would you know whether it is running inside a container? Do ls. So you can see here our app.jar, which is located inside a container. So you can also do ps -ef grep, then Java. Okay, so PS command is not found. If at all, if you want to test it, you can install the PS command inside a container, right? So yeah, so you can do that. Now we are inside a container, so our application is running fine. So I think I have not written any logs. If you are writing some logs, we should be able to see our application logs as well. So that's all, guys, for this video. Thank you so much for watching this video. If you like this video, please do subscribe and like and share with your friends.